Converting a Farish Class 50 to DCC? How hard can that be? Okay, so today I'm back at my workbench and I'm going to be working on a loco. I've got this Class 50 and I need to convert it to DCC. I want to try and add some sound to it well, let's just have a look first because it's a slightly unusual thing. It's a Class 50, number 50017. But it's painted up in LMS Crimson Lake. Now, that doesn't really make any sense because LMS have been nationalised by the time Class 50 started running. But this actual loco, this model is a model of a loco that's now a heritage model, a heritage loco. And for whatever reason, I'm not quite sure, I suppose I could do some research and find out, but for whatever reason, it was at one point painted up in LMS Crimson Lake. And that's what this is a model of. I'm going to run it on my layout. Not quite sure exactly what time period my layout is. I'm thinking probably somewhere around 1937. So obviously this wouldn't have existed, but I think this is a bit of fun. I'll just have it pop out of a tunnel every now and again and make an appearance. It's also a good excuse for me to be able to run a diesel on my layout. Otherwise I wouldn't have any diesels. That's a whole area of modelling that otherwise I wouldn't be able to use. In particular, I'm keen to see how well it pulls compared to the steam locos. It might change my opinion about the time period I want to model. Perhaps I'll completely change my approach based on the fact that this can get up the hills and the steam locos can't. Anyway, let's have a look. There we go. Now, I will admit I have had a look at this before and I have taken it to bits already. So I do know my way around it a little bit. I know in my videos I like to give you a sort of honest appraisal of me making a mess of things. But I've been waiting a long time to make this video, so I have already had a look. So here it is. I'll put some pictures up, and a very handsome model it is too. It currently has no sort of DCC capability. It's not doesn't have a DCC chip. It's not DCC ready. And what I want to do is, instead of just wiring in a DCC chip, I want to add in one of these. Now this is a socket for a Next 18 style decoder, which is a style of decoder that's sort of designed for N-gauge really. It's small enough to fit in most N-gauge locos. And the idea is that you hardwire in this board, and then you can swap in different decoders, plug in. Eventually I want to put in a sound decoder, but maybe just to get me going, I might just put in a sort of non-sound decoder to get it running. The other advantage is that when I do put in the sound decoder, the speaker can be hardwired onto this board. So I don't, the speaker's sort of built into the loco, and then the actual decoder can come and go. And obviously I'll be able to get a sound decoder with sounds for Class 50 on it. So I'll put a picture of this up so you can have a close look. It's got a very fine plug on one end that's got 18 connectors, presumably. And on the back, it has a bunch of solder pads. So what I'll be able to do is to run wires to the various solder pads, and then place it and then plug in the connector on the other side. And obviously, once the soldering's done, I can attach this to the actual model. So in order to find somewhere where I can put the decoder, I'm going to have a look inside the model. And I think in order to do that, I'm going to need to reposition my camera. Okay, so I'm all set. Here's my loco. Now I've got it in my tray here, and the idea of this is to make sure I don't lose anything. But I got a tip off someone who commented on one of my videos. I'm sorry, I can't remember who it is, but I'll put it up in a caption. And that is to line your tray with a bit of towel or something. So I've got a tea towel here. Now the idea of this is that when you drop a screw or whatever, it doesn't go flying off into the corner of the room and getting lost in the carpet. So we'll give this a go, see if this works any better. So here I've got my loco. So I'll be taking the lid off this in a moment. I'll just show you the other parts that I'm going to use. So I mentioned this holder for an X18 decoder. And there you can see there's solder pads on the other side. And I'm also going to be using this, which is a speaker I got off YouTube. This they call a sugar curve speaker. It's the smallest one they've got. I don't know what it sounds like, if it's any good. The key point here is that it's got a slightly curved top, and my hope is I'm going to be able to fit it in a bit of space in the roof here. But I'll show you once I take the lid off how that might work. I've also got here an X18 blanking chip, and I can use that to see if it runs on DC once I've done the conversion, and before I commit a DCC chip to it and potentially blow that up. So that'll be a good start. Now really what I ought to do before I do anything else is to just see if it runs on DC on a piece of track, and I'll do that in a moment. But I just want to have a look inside first. So in order to take it apart, I think you just have to get a thumbnail under here. Just pull it outwards a little bit. I think there's 2 tabs on either side, 2 clips. So just pull it out a little bit, one and the other. And then if I turn it over, I could slide a little bit of plastic card or whatever in there. Hopefully I won't need, there you go. Hopefully I won't need to. We'll just get the last one out. Obviously being gentle with these things is the key. There we go. I don't want to damage it. So there's the lid, there's the model, and here's the chassis and the mechanism and so on. Now, just inside here, you can see, let me see if I get something to point with. This might work. You can see there's a couple of cross pieces, which will lie on top of the flat lid here. So there is in fact a bit of space in the roof. And I've used my caliper to measure the depth of this. And I think I can just about get this speaker inside. So the first thing to do is to do a bit of a test fit, just to see if it'll work at all. And I can drop the speaker in. Whoops. There we go. So the speaker's in there. And really what I ought to do is to get a proper X18 decoder, sound decoder. So this blanking plate obviously doesn't have much electronics on it. An actual decoder would be bigger. Now I believe the X18 specification also includes a physical specification of how large, how much space an X18 decoder can take up. The idea is that, if a decoder conforms to that specification, then it'll be able to fit in a particular space. But let's just see if this works at all to start with. So I'll put that in the next compartment along, and I'll just see if I can put the lid back on the train, put the lid back on the locomotive. You can see just here and here, this is where the clips clip on. I don't think it's quite symmetric, so you can't put this the wrong way around. Again, as always, whoops, oh dear, the speaker's come out something. What's going on there? Or was that because it's magnetic? It's all gone. Or was the magnets in the perhaps there's magnets in the motor. In fact, maybe that means I need to not put the speaker in the middle. If I put the speaker on the edge there, it might go better for me. So if I just slide this in, the hope is it'll click and the lid will go on without. There we go. So that seems to have gone back together, and I've got a mounting board, with a blanking chip in it, and a speaker in there. They do rattle a little bit, so maybe there's a little bit more space, but that's a good start. So the next thing I want to try then is to get a proper size sound decoder to check that fits. Okay, so I've got here my Stania 8F, and this has a Next18 sound decoder fitted. It goes here in the tender. Now this is quite simple. The top just pulls off. Simple as that. So I will take the sound decoder out, and you can see this has a mounting board as well. There we go. So that's got a mounting board, obviously one that's bespoke to this loco. But here's the Next18 sound decoder. You can see this is obviously a much more complicated piece of electronics than the blanking plate. In particular, it even has some solder pads here. You can solder extra things onto it. I won't be doing that. Terrified to go near this. But that's good. Let me get the 8F out of the way. Be very careful not to damage these things. So if I fit the sound decoder into my blanking plate, I'm not quite sure how this is going to work. There we go, that snaps in nicely. So that's obviously a bit deeper than it was, but I don't think it's no deeper really than the speaker. So if the speaker fits, I hope this will fit. So we'll give that a go. We'll pop that in there. That fits in that little compartment, so that's a good start. And in fact, the compartment on the other side is a bit wider. Let me put it in there. So that's the decoder. Here goes the speaker. We're leaving the middle open. There's another compartment there in the middle. We'll leave that open because of the magnets in the motor. We don't want that to interfere with anything. And we'll see if we can pop the lid back on. That seems quite good. Yeah, and that's snapped on. So that's fantastic. So that looks like I'm going to be able to get all those components inside. There's a bit more of a challenge. There's obviously I have to solder the wires onto the blanking plate first, and I also have to provide some insulation to insulate the blanking plate from the chassis. I don't want it to short out across those metal components. But I suspect I'm going to be able to make this happen. I do have an option if it doesn't quite fit, and I'll explain to you what that is. Hold on, let me get the lid off. There we go. So if it doesn't quite fit, I can just take a file to the top here and just take maybe a millimetre, half a millimetre of material out the top in order to create a bit of an indent and give me a little bit more space. But hopefully I won't have to do that. Okay, so the next thing I want to do is to just take this apart and work out how this all works. So I will put away the body shell, and I've got the speaker and the decoder and the blanking plate in there. Oops. There we go, and I'll just put it away in the box. So that's nice and safe. Right. So from what I can work out, the way this works, it's sort of encased in this sort of metal chassis, which is in two halves. There's left half and right half, and I believe they're electrically insulated from each other. We'll check that in a moment. The pickups from the wheels make contact with either side, and the motor, which is in the middle here, there we go, that's the motor. The brushes for that also make contact with this metal piece here. So in order to do the DCC conversion, I think all I need to do is to somehow insulate the motor from this piece of metal and all these pieces of metal, and then take wires from either side of that chassis to feed the decoder, and then obviously take the motor output from the decoder and connect that to the actual brushes of the motor. The whole thing's held together by these two screws, so seems reasonably obvious that we need to just take those screws out. The first thing we can do is to take this, I assume this is like the fuel tank or whatever, on the bottom, the machinery on the underside. So I'll just disconnect that first. There's a screw on the bottom that takes that out. There we go. You can see a little bit more clearly. This is the motor here. And there's two brass flywheels either side. That's good because brass flywheels make it run a bit better. It's less likely to stall because the flywheels will keep it going. So if I take these screws out, right, and that's fallen apart quite nicely. So let's see if we can see what's in here. This is the motor. That's the brush, one side of the brush, which is connecting with this metal piece. You can see the two brass flywheels either side. These are sort of plastic insulators that the screws go into. And these are what we call them, the motorized bogies. They're designed so they can turn a bit, as obviously they would. And here you've got these shafts which fit into the end of the brass flywheels. Now, something you need to do is to note the position of this plastic piece that holds the bogie in place, and I can see it's on the last dimple, but there's several dimples here, so presumably for a different model they can use the same innards and they can reposition the bogies slightly closer together if that's what they want. But I believe, I've taken this apart before, on both ends it's on the outermost dimple. See here, this one's fallen out already. There's also a dot on one side of this, and I've noticed that dot goes on the outside most faces outwards, and that makes a difference as well. So when it goes back together, that goes in the top, and then these two sides go together. It's a hell of a thing to put back together, I've discovered. Anyway, we'll take the two motorised bogies out the way, and we can concentrate on the electrics. So you'll see on either side of the motorised bogies, this is the wipers on the wheels, pickups from the wheels, and then they connect to the spring here, which touches the metal side on both sides. And then if we have a look at how the motor is powered, this connector here, this is the brush, and that makes contact with this piece of metal here, which is there. And the same on the other side. So I think what I need to do is to just remove this section of metal and instead attach a wire, solder a wire onto this this connector here, this sort of brush spring, and that is all I need to do in order to isolate the motor from the pickups. So I'll take the motor out of here because obviously I'll need to make the same adjustment on the other side, and then we can see the motor with the flywheels. There we go. So you can see the brushes. That's the commutator in there. These are the two brushes. You'll see the coils of the motor and the magnets on either side, which are clearly magnetic. Now another thing I need to consider is how am I going to make an electrical connection from these bits of the metal chassis onto the wires that are soldered onto the mounting board for the decoder. And I think what I want to do is just to use these screws. So where they connect, where they screw in here, just to wrap a wire around the screw and have it make contact with the metal piece here. So I'll need to just clean the paint, this black paint off these metal pieces to make sure I get a good electrical connection. And of course I don't want them both going on connecting to the same side, obviously, because one connects to one side and one connects to the other. Now these screws screw into these plastic pieces here. So what I'm actually going to do is I'm going to swap one of these over. Here we go. If I take this out, there we go. So it's actually two pieces. There's this piece of plastic that the screw screws into, and then there's this plastic ring that obviously acts as an insulator to hold the two halves apart. So I'll put this one in on this side, put the plastic insulator on. So I'll have one wire coming off here, off this part, on that side, and I'll have another wire making a connection there. Now, there's one more part that I haven't talked about, and that's this little black piece of plastic here, and that just slots in to this slot here and this slot here, and it keeps the two halves separated at the bottom of the model, and it also provides something for the screw to screw into that holds this this fuel tank piece of plastic on the bottom. It's as simple as that. Well, I don't think there's anything else really to talk about. I think the next thing I need to do is to start chopping up these bits of metal. to remove these connectors here so that I can isolate the bush. So I'll get on and start doing that. Okay, so this is my makeshift metal chop. This is the piece I'm working on, and I need to remove this material here. Now there's several ways I can do this. I've got a whole bunch of files here to file away, but I think what I'm actually going to do is just to try and drill it out to start with. I've got a sort of sacrificial piece of MDF here to save the table. But the table's probably made of chipboard and isn't really worth saving, but never mind. And I will just clamp this down using a couple of clamps. Hold it in place. Hopefully this will work. There we go. So that'll keep that in place. Obviously the camera's mounted on the table, so I expect it'll all go crazy. And I'm going to use power drill. I've got here, I think this is 2mm bit. Right, so that's good. So I'm just going to take out sort of the corners and then possibly work along the straight edges. But let me just see how this works. This might be a good thing, this might be a disaster. Anyway, I didn't spend too much on the model, so there's a limit to how bad it can turn out. Let's give it a go. Right, let me show you what's happened. So I have drilled a hole. I'm sure someone who's experienced metal worker will tell me that what I'm doing is a complete disaster. But given the tools and the skills that I have, I think this hopefully will work. Got most of the material out, and I think with some pliers I might just be able to use a bit of brute force. So that's removed most of the material. I think I just tidy it up with a file now. Okay, so I filed away, and I believe this is as good a job as I'm going to get. You'll see I've tidied it up. It's smooth to the outside, and on the inside there I've removed any loose pieces. I don't want to file too much. I don't want to take away more than I need to. It's quite soft metal, so it's not hard to file, so that's a good thing. Obviously I just need to do the other side, and then clear it all up, clear up any bits of loose metal, and then I'll see how the motor fits in the middle there. So if I reintroduce the motor, we'll see how well this fits. Just pops in there very nicely, and you'll see that we have almost exposed the bush here. I'm a little bit worried it's still going to make an electrical connection on the edge there. So there, I may need to do something to insulate it, or perhaps, well, I don't want to take away more material because I don't want to, well, maybe I can. Okay, so I've got my multimeter here. If I put it onto ohms, continuity, and we'll see if there's a electrical connection between the bush here and the chassis. Oops. And it seems that there sort of is. So I think we're going to have to take a little bit more material off. In order to insulate it. So if I take a small sliver, if I just file this down a bit more, and then I think what I'll do is I will put some Kapton tape on there in order to insulate it. So here I've got some tape. I've never used this before. Let's see if I can cut a small piece to be just the right sort of size. Now this may or may not be a good idea, I have no idea if this is going to work or not. You'll see if that insulates the motor or not. So there we go. So I've put the motor in. And let's test it with the multimeter. So if we go from the bush to the chassis. I think we're doing all right there. I think that's worked. So I'm quite pleased about that. There's one more thing to do, and that is to just file off here where the screw connects in order to make sure we get a good electrical connection with the wire connecting to the chassis. So I'll do that now. Okay, well I'm very pleased with that. I've just filed these off here. I've got the Kapton tape here just insulating the bush, and I think that's going to work. So I will just do the same preparation with the other half as well. Okay, so I've reassembled things a bit. You can see here there's the two halves screwed together. I've got the motor in there, and you can see here the bushes on each side of the motor are exposed. There's the Kapton tape there insulating from the chassis, and I've also attached these wires here where I've screwed it back together, one on each side. So I want to use the multimeter just to check that everything's connected the way I imagine it is. So the first thing is, does the end of this wire connect to the side of the chassis? And there we go, that's a good connection, 0 ohms. Try the other side. It's the black side connect to this chassis, and it looks like it does. That's pretty good. So then does this, well, the next thing, do the two sides of the chassis insulated from each other? So if I check the two wires, there shouldn't be a connection there, which there isn't, of course. Now, if this connector here, this bush, does that connect to the chassis? And no, it doesn't. And does it connect to the wire? No, it doesn't. Let me try that on the other side. Does this wire the red wire does connect to the chassis, but it doesn't connect to the motor. And we'll just check the motor doesn't connect to the chassis. So that's good. So we've managed to isolate the motor from the chassis, which is what I was trying to achieve to start with. That's fantastic. So just to sort of review what these wires are. So these two wires will be the connections from the track. They go to the decoder. I also need to attach two more wires going to the motor either side. And I think there's a bit of an issue about how I route those wires. And I think the best thing to do is just to cut a bit of a channel. If I just file out a channel there and on the other side as well there, then I can press the wires into that channel. So I'll do that now and then solder onto the motor here. And I think it's that soldering onto the motor that's where everything might go wrong. Okay, so I think I've finished preparing these pieces. So you'll see I've removed this material here. I've used some tape to insulate this area, and I've cut a groove there so that a wire coming from the motor can lie in that groove and not be pressed tight against the case. And I've done the same on this one here as well. There you go. I've removed that. I've used some tape, particularly on this surface here, and I've cut a groove just there. Okay, so the next step is to solder on some wires to the motor here. Now you'll see, well, you probably can't, but I can tell you, these brass pads here that I'm hoping to solder onto, just there and just there, they in fact are the other side of a spring. Presumably the spring holds the actual brush in place. So I don't want to sort of cover the whole thing in solder and make a real mess of it. I just a very light dab of solder on the top and then solder on the wire. So I think this is where it all has the potential to go wrong. I'm a bit worried about this, but I will just do my best. I suppose if I make a mess of it, I can probably get a replacement motor as a spare part. In DCC, the wires that are supposed to go to the motor, I believe, are supposed to be orange and grey to distinguish them from the black and red that go to the track. Now, I don't have orange and grey wire, so I'm going to use white and yellow. I really don't think it's going to make any difference. I expect white and yellow means something else in DCC world. So I have the potential to confuse myself here, but I don't have 100 different colours of wire. So I will, I'll tin these wires. First of all, dip them in flux. Now, I'm really not very good at soldering, so this isn't going to look very good, I'm afraid. This is what it is. We have to do our best when it comes to soldering, don't we? I think I might need some flux to get the solder to adhere to the brass. There's a tiny blob of solder on the top there. So hopefully that's good enough. Snip off the excess. We'll try the same on the other side. As soon as this gets hot, the insulation pulls back, so that's a bit of an issue. But I think that's attached, so I think that's nicely done. So now all I need to do is just put the whole thing back together. So I will feed this wire through there. And then this one go through there. Lay the cables in those grooves that we've cut out. So that's how the whole thing's going to hold together. And now I just need some screws. Now, if this all works out and electrically it's all isolated and connected and somewhere where it should be, I'm going to have to take it to bits again because I then got to put the driving bogies in. But it will be a good step first just to know that all the electrical connections are correct. Okay, so what I'm going to do now is try and put it back together mechanically. So put these motorized bogies back in. And then I can see if I can drive it along a piece of track by applying a voltage across the motor. Now this isn't an easy thing to do. I'm trying to remember how I did it last time I took it apart. I think what I'll do, I'll take these screws out. These screws are getting damaged. I'm starting to strip the thread, strip the head, which isn't a good thing. There we go, that's one out. And I will very gently take this off. It's not going to be that gentle because of this wire. There we go. And what I need to do is to put the driving shaft here into the flywheel, just there, and then get this piece in place. And I've discovered a bit of a cheat, which is to use a piece of tape. And I'm going to just use this piece of tape to hold that in place. That, I believe, is going to make everything a lot easier. I've got to do the same thing on this one. I'll put it with the dots. There's a little dot that goes on the outside, so it goes that way around. Put the driving shaft in. There we go. That's going to be right, and another piece of tape just to hold it all together. And then I just need to put this back together. So there's a lot of things that all need to slot in. It's very easy to make a mess of this. I'll see if I can get one of these screws in. So I need to turn the whole thing over to put the other screw in, and that's where everything falls apart. So this can be a real challenge. And try and get the other screw in. I think this looks quite good actually. Touch wood. So these bogies, they can rotate. They're not sliding up and down. If I take the tape off, I can see that this piece is in this furthest outermost bobble. This one isn't quite. This isn't quite right. It's in the middle of a bobble. So that's no good. I've made a mess of that. Let me loosen this off. Pretty much stripped the head on that screw, so I'm not going to have much more chance to do more work on this. If I can get this wire into that groove, like that. That one's up together. Now, if I apply a voltage across here, that should power the motor. Drive the wheels along the track. Let's give it a go. Okay, so I've got just a little piece of test track here. It's actually my programming track. I've unplugged it from the layout. And I'm just going to put the loco chassis on here. And here I've got a dodgy old Hornby DC controller. But what I'm going to do is just turn it on, attach the wires here to the motor and see if anything moves. So this is the moment of truth. And there is a bit of movement there. So that's not bad, is it? Other way around. Well, that I think looks pretty good. So the next bit is going to be to work out where to put these components on the top. So I need to put the speaker somewhere and mount the chip, the decoder, or the mounting board for the decoder. If I have a look inside here, you may be able to see there is a couple of strengthening sort of ribs that go across the top. So that divides the thing up into 3 sections. And so really what I need to do is to work out where those ribs go when the thing's clipped on. Now there's these 2 clips on either side, and in fact they're a different distance from the end. So in fact this only goes on one way round, and in fact it goes that way round rather than the other way, I think. Because if you can see, but there's a clip there, and they slide in and clip in there and there, and you can see this one is further this way than this one is from that way. Now it does look as if these 2 ribs are equidistant from the clips, so what I'm going to do is use my digital caliper here. I close it up, zero it out, to measure the distance between the rib and the clip. There we go. So that's 6 millimeters. And the other one is also, there we go, 5.7. So if I set this to 6 millimeters, there we go. So I can position that line about there and about there. So I can draw those on, and then I'll know where those ribs are, and I can lay out the components on the top. Okay, I've had a little go off camera, I don't want to bore you, and I've put tape. I've done my measurements and I've put tape on either side to insulate this metal chassis from whatever goes above. And I've done it up to around about where those 2 cross pieces are going to go. So that's the chassis. So sorry, that's the inside of the shell. And you can see, oops, you can see the 2 cross pieces there and there, and they sort of pretty much line up with where this is. So I will then mount the mounting board for the decoder, and if I put the speaker there somewhere, and then I know that everything's sort of going to be in the right place. The next thing I'm going to do, having worked that out, is I'm going to solder this on to these wires. I'm not going to sort of do it properly. I'm just going to solder it on loosely, because what I want to do is I just want to check that the thing dries by picking up power from the track and going through the blanking plate. Once I've done that, I can then put a decoder on. And I can check that works, and then once I've attached the decoder, I can then solder on some wires for the speaker. I check the speaker works, and once I know everything works electrically, I'll then mount it appropriately within the shell. Okay, so having a look at the mounting plate, just trying to work out everything, what's what. I know I've got, that's rail L, so that'll be rail left. Here I've got rail R. Now it's not clear where that refers to, but I think it might be this pad here, because it says rail R and then LS, which I believe stands for loudspeaker. So I think that one's loudspeaker, and then this one says loudspeaker as well, LS there. So I think that and that are the loudspeakers. That's that one and that one are the rails. And then here I've got M plus and M minus, which I believe means the motor. There's then a few other ones. There's F1, F2. Where are we? F1, I'm not sure if I can see that. F2, F3, F4. There you go, there's F1, F1, F2, F3, F4. So I assume that's functions 1 to 4. FL, I assume that means function lights, perhaps, or forward lights. And RL, reverse lights, that makes sense. And then there's a ground. And that says plus VE, perhaps that's just positive voltage, I'm not sure. But I think I've identified most of the pads, and I think I've identified the ones I need, which is the motor, the loudspeaker, and the rails. So I'll get on. I'll solder in the rails and the motor, and then I'll see if I can get it to drive. There's a tiny bit of flux there on the board. And I put some flux on all of these cables. Now I'm going to later remove all this, cut things to length and do it again. But this will do to start with. Okay, so I'll just tin the wires first. Trim these off a bit as well. And I'll do one at a time. Right. So the white and the yellow go to the motor. For me, that's non-standard. Normally it's grey and orange. But I don't have grey and orange, so I'm using white and yellow. Now I just gotta tin the pad first. And then that should enable me to get a good connection. There you go. Blob of solder on the pad. So I really don't, what I don't want this to be is like a big blob that sticks out. Because if it ends up being a big blob that sticks out, then I'm not gonna be able to mount it sort of low and get it to fit inside the roof, inside the shell. Gosh, this is hard. So those both seem attached, but I'm unhappy because the insulation doesn't reach the end of the wire. What I really don't want to do is end up shorting things out and blowing up the decoder. I might redo this yellow one in particular. That's better. Much better. Okay, and now to do the two rails, the two pickups. Just a tiny dab of solder. Okay, so here you can see that the 4 wires are all connected to the mounting board. There's various things that could be better about all this, but let's see if I can move this insulation along a bit. Yeah, a little bit. Anyway, so all I've got to do is plug in the blanking plate, which is this one, which I believe just all it does is connect them up, and then I should be able to drive this along some track. Right, so I've got my track here again. I'm ready to have a little test run. So let's put the loco on the track. So it's wired up, the blanking plate's attached, plugged in. So it should just run like a DC loco. With that in mind, I've got my DC controller here, and I'll just turn it all the way up one way or the other. Let's see what happens when oh dear. What happens is I drop it on the floor and the power bogie falls out. And annoyingly, it snapped the pin off there, so that's actually properly broken. That is really devastating. I'm going to have to try and super glue that back on. Start again.